Hey guys, this next question asks us to give the equation of this graph below. It's a little bit different to last time. Last time we had a linear graph, this time it is quadratic. So the first thing we're going to do is plot some points that we can see. We have these 3 points here. We have the two x-intercepts. We've also got the y-intercept also at the x-intercept. They are the same point, and the turning point down here at the bottom. That turning point being called the vertex. So the equation of the graph, when we are doing quadratics, we have a choice. We could either use standard form, which looks like this, or factored form, which looks like this, or vertex form, which looks like this. Each one has its advantages. This first one is good when you've got a table of values. This second one is good when you know the x-intercepts. And this third one is good when you know the vertex. In our case, we know both the x-intercept and the vertex. We're not given a table of values, so we could use either one of these two forms. For this question, I'm just going to use the vertex form for no real reason, just because I want to. So the first thing we'll do is just put in where the vertex is. The vertex is this turning point here. This vertex here is at -2 on the x-axis and -4 on the y-axis. The way we put that into the equation is that the b here is our x value, but with the opposite sign. So instead of -2, it's actually +2. We square that, and then we add to that the y value of the vertex, which is at -4. Now usually we don't really write plus -4. Instead, we just write -4 because adding a negative is the same as minusing. We've got almost everything we need. We just need to find out what that a value is. Now there's multiple ways of doing this. First way is by patterns. So if we take a look at the graph, if we go across one and up one, and we end up back on the graph, then we have a good idea that maybe that a value is a 1. If we go across 1 and up 3, we should again end up back on the graph. Across 1 and up 3, we do end up on the graph, so that a value is 1. Now usually we don't write ones when we're multiplying them, so we're just going to go ahead and delete that, and that is our final equation. Of course, there is another way of doing it other than just that pattern, so let's delete all of that and go back to our equation. So we want to know what this a value is. The way to do that is to pick one of these x-intercepts. We're going to use this value here, which is at -4, 0. So 0 is our y-axis. That y there is 0 equals a times x, x is -4, plus 2 squared minus 4. Let's just simplify this and see what we get. So we have a equals a times -2 plus 2. -2 plus 2 means we're getting close to 0, so that becomes -2. And then we square that in -4. Our goal here is to get that a by itself, so we need to get this 4 off to the other side of the equal sign. The way to do that is to add 4 to both sides. So that gives us 4 over here equals a times -2 squared. -2 squared, if you put that into a calculator without brackets, you'll end up with the wrong answer. So when you put -2 squared into a calculator, make sure you use your brackets. The answer to that is 4. We have a times 4. We don't want a times 4, we just want 1a. So we have to divide by 4 because divide is the inverse of multiplication. Dividing by 4 means we divide both sides or everything by 4. On the left hand side we have 4 divided by 4, which is 1. And on the right hand side we have a times 1. We don't usually write times 1s, so that is a equals 1. And our final equation is y equals 1 times x plus 2 squared minus 4. And that's how we find an equation for this parabola. See you next time.